Hi there. After getting introduced to the CBA, now we will see that what steps are involved in this process. They are 9 in number, and let us start with the first one. The first one is to set the alternative projects, and in this process we list all the possible alternatives that we have in order to achieve the same objective. Now the thing is that we can come up with a large number of alternatives, and this is because there are many dimensions and there are many possible values of those dimensions. And when we combine those dimensions with their possible values, the alternatives can be even larger in number. So now this is the formula that we can use to come up with all the alternatives. Now we are taking an example of Coquihalla Highway, which is in British Columbia, and the possible dimensions, they are n in number, and their values, they are k in number. For example, if the road surface, it can be made of bitumen or concrete. So these are two dimensions. And what are the possible values? That what will be the concentration of bitumen or concrete is another set of possibilities. Then what will be the route that it will follow? There can be different routes. Number of routes and how they will vary in terms of their displacements and angles and twists. So another set of possibilities they arise. Then we talk about the dimension of size of the highway. It can have 2 lanes, it can have 3 lanes, 4, or any number of lanes which is feasible. So another set of possibilities arise. Then the other set of possibilities is with the tolls. We can have tolls or no tolls, and if we have tolls, we can have higher tolls or lower tolls. So you see, within that dimension there is a number of possible values that can be used. Wild animal friendliness, it can be there. We can make some elk tunnels or some sort of bridges so that the wild animals, they could pass from above the or below the highway, from one side to the other side of the highway. So this is another dimension. Timing can be changed. We can start the project at a certain date or after that certain date or even later. So another set of possibilities arise. So we can see already that there is quite a number of possibilities that can be there, and hence the first step is about defining those alternatives, which can be quite cumbersome. And let us see that how the analysis of about 2 dimensions of these can be conducted, because the CBA conducts the social benefits comparison with the costs, that is the social costs. We have NSB, that is net social benefits. Here we are assuming that the project, if it is undertaken or if it is not undertaken. If the project is undertaken and the NSB is greater than the NSB of the counterfactual or the status quo, then the project should be undertaken. But if the NSB of the counterfactual or the status quo is greater, then we should not undertake the project. So out of these dimensions, this is a table that lists 2 of them, that is tolls or no tolls. And further we have the perspectives. These perspectives can be from global point of view or national point of view or provincial point of view or local point of view. So you see, various geographical jurisdictions can be used to develop these perspectives. We have taken these 2 perspectives, that is global and the provincial perspectives. Under the no toll dimension or with toll dimension, A, B, C, D, there are 4 possibilities that we will consider in this table, which is attributed to these authors. This is the reference. Now the project benefits and the project costs, they are listed in these two broader rows. This is the final row which shows the total benefits, and this is the final row within this row which shows the total costs, the second last row, and the final row is basically the net social benefits, that is NSB. So we will add these benefits, we will add these costs, and then take the difference of the two. The first benefit is the time and the operating cost savings. When we have highway of this magnitude, the time will be saved and the operating cost will also be saved. The horizon value of the highway will also be there, the value of the highway at the end of the project when the project is completed. And then safety benefits will be there, some lives will be saved, and we can try to monetize this value. Here we have tried to do so. The alternative route benefits will arise because the alternative routes will be having less traffic congestion, due to which there will be lesser costs and damages. That can be termed as the benefits, because the costs avoided, they become benefits. Then we have toll revenues. Toll revenues will be accumulated, which becomes another benefit. Benefits of having new users will also be there. So we can collect these values, just a glimpse of how these values are changing across these perspectives and dimensions. This is having the highest value, that is from the global perspective, and definitely it is higher than the with tolls option. And again, the provincial perspective is having a higher value as compared to the provincial perspective under the with tolls dimensions. This is quite evident because when we do not have any tolls, more people will travel. So therefore, you can see the values are declining in the with tolls option. The horizon value is assumed to be the same no matter we have tolls or not. At the end of the project life remaining value, it will remain the same. More people will travel and more safety will be there for more people, so greater values as compared to with tolls options. Alternative route benefits will be greater because more people are traveling and more benefits are there, or more costs are saved. When the toll revenue matter is there, the provincial perspective will show us a certain value, that the revenues are accumulated when there are tolls. From the local point of view, that is the provincial point of view. And there are new users. In this case, the highest number of new users are there. In terms of their monetary value, we have mentioned the benefits. So you see the benefits are the highest in these cases, where it becomes lower here in this dimension. When we talk about the project cost, the construction cost of the highway will remain the same. The construction cost of the toll booth will be there. The toll booth construction cost will be there as the same in these two perspectives, that is with tolls. No matter it is global perspective or provincial, tolls will be the same. So these are the two construction costs. When we come to maintenance, the maintenance cost of the highway will be here. The toll collection will be there in these two cases, because here there is no toll, so there will be no toll collection. Toll costs, total costs are there, so these are the total costs. Now this row and this row can be used for subtraction to get the net social benefits, and these are the answers. So clearly we can see that this part, this option, that is no tolls from the global perspective, is giving us the highest NSB value, and then the value declines when we move from left to right, and this has the negative value. So clearly with tolls option from the provincial perspective is the worst option to have. But here we are not going to take the decision, because we have to see other steps as well, and at the end we will see the decision. Due to the large number of possibilities, the politicians and the decision makers, they think that CBA is a kind of tool or a magical machine that can rank all the possible alternatives. But we know that there is a cost of CBA which involves the time component, human component, and other financial constraints, due to which it is not possible to rank all the alternatives because the quantification of B's and C's will be a cumbersome task for such large number of alternatives. Then we have the step 2 of CBA, in which we decide that whose benefits and costs will matter. And this will be termed as standing. The standing will be of those people who have their stakes in this project. So usually we keep the standing to the national level, but it can be shrunk to a lower level or can be extended to a higher level if and when needed. So the contention can be there when it comes to the decision that if it should be extended to the global level. And these are the issues, for example, like ozone layer issue, that if the actions of one country are affecting the other country in terms of their ozone layer, because ozone layer, when this gets damaged, all the nations, they get affected. Also, the international spillover of global warming can be there. So it has to be considered that what are the international spillovers of the certain intervention. Other levels of standing are also there, that is at state level, provincial level, or local government level. All these possibilities are there, and we have to choose that which level of standing we should use for determining the benefits and the costs. Once we have determined the standing, then we can list those benefits and costs and also select their measurement indicators, because we have to measure them in order to be able to conduct the comparison and the analysis of costs and benefits. So we try to do this process. If the benefits and the costs are physical in nature, it is relatively easy. But when they are not, then it becomes difficult, and then we have to delve deeper into them and try to quantify them. Impacts, they are inputs and outputs, that is benefits and the costs. Inputs are the costs and the outputs are the benefits. Impacts can also include the effect on the individual utility of human beings. That is how people are benefiting from the cost-effective travel from some BRT, that is bus rapid transit, or any other train service, for example Orange Line train. This is the project outcome of a project, that is the Orange Line train, and it can provide cost-effective travel to the individuals, hence affecting their utility. So the cause and effect relationship is understood in this, so that we understand the benefits and the costs in the process. However, there are some caveats, and the perspective and specification and measurement caveats, they are there. For example, the benefits and the costs, they can differ when it comes to different individuals. For some people there are some benefits, and for other people those benefits will be some sort of cost. For example, if the travelers are benefiting from such an Orange Line train, the people who used to drive or other smaller public transport, for example rickshaws or taxis, they will pay the price in terms of reduced income. So that becomes the cost. So now the perspective is opposite, and some people are having benefits from that intervention, some people are having costs from that intervention. So now we have these two opposite things. What we can do is that we can make two separate categories, that is the traveler benefits and the rickshaw driver costs. They should be separated, and their net effect will determine if we are actually benefiting in this regard or having a loss. Then the other caveat is regarding the specification. The specification can be challenging in the environmental sort of situations. For example, what should be included as the impact of environmental pollution? How can we specify the environmental pollution? That is, in terms of the pollutants in the environment, what quantity of the pollutants has arisen, or what are the effects of these pollutants in the environment in the form of mortality or morbidity of the individuals. So there are two possibilities here at least, and then in terms of their mortality or morbidity comes the choice of the resultant health effects. So this is another challenge that we face when it comes to cataloging and selecting the measurement indicators of the impacts. The other concern that we have is of measurement, because the measurement can be a little wrong when it comes to situations where we are trying to consider a policy intervention, where we are trying to see that if the crimes are really avoided, is there some reduction due to some intervention? And in that, the changes in the arrest rates or changes in the conviction rates, or both, we can use. However, what happens is that if the conviction rate is increasing, it does not necessarily mean that the crime rate has actually decreased. Previously, lesser crimes were being taken to the level of conviction, but recently, if it has increased, it doesn't mean that the crime rate has also changed. It might be the same. Since conviction rate is a more reported unit, the crime rate is not properly reported. We depend more on conviction rate, and it can give us an underestimation of the actual crime rate. So similar situations can arise in different interventions, and we have to be careful when it comes to the selection of the measurement indicators. Then we have the fourth step, in which we try to quantify those impacts that we have cataloged, and this is definitely a difficult task because of the minor details in it. Another issue is that the supply and the demand curves of such phenomena are not usually known. So choosing the conceptually correct method of quantification gets lost. For example, we are considering the life of a project. If it increases, if it is a lengthier project, the complexity in the quantification of impacts will also increase, because we will have to quantify the benefits and the costs over a longer span of time. Now we take the example of the highway and see that how the quantification can be done. For example, if such a data is available, that is the number of vehicle trips on the new highway, the number of vehicle trips on the old roads, and the proportion of travelers from British Columbia. This is a set of some variables that we can have the data of, and it is known that the highway is 195 kilometer long, and analysts now they can estimate a few things. For example, they can estimate that the total vehicle operating costs that users save, this is something that they can try to estimate. They can also try to estimate the number of accidents that are avoided due to the newer highway. And most importantly, they can try to find out the number of the lives that are saved due to this highway. So let's try to delve deeper into this variable. The lives that are saved, they are basically saved due to two reasons. One is that the distance is now shorter, and now they are traveling. Assuming that the newer highway is shorter, then the travel will also reduce, and that will reduce by 130 vehicle kilometer. it means that this is the reduction in the travel and the lives that are saved per vehicle kilometer. It is 0.027. This is an empirical evidence which is already available, so we can use this. Now multiplying these will give us that what is the number of lives saved per year, because these estimates are for 1 year. These are annual estimates. Now the other reason for saving lives is that there is safer travel, and safer travel is because that there are more lanes as compared to the older highways. So this will also reduce the lives lost. Travel on the new highway is now this much, and lives lost per vehicle kilometer are this. This is something we have done before. This is the same value that we have used before, and now this is the reduction in the lives lost per vehicle kilometer. So we multiply this with the lives lost per vehicle kilometer. It will reduce this value of 0.027 further, and we will multiply it with 313, which is the travel on new highway. So this will give us the lives saved due to safer travel. This was due to shorter travel because this much of the distance was avoided due to new highway, which was shorter in distance. Now summing these two values, we can get the total lives saved, and you can see lives saved due to shorter distance and due to safer distance or safer travel. Now we get this, that is 6.5 lives per year. This is the total lives saved. It is an approximate value. This is why we can see it is 6.5 and is not giving any whole number where we can say that 6 lives saved or 7 lives saved. So it's an estimate, and even a single life saved is priceless. Now we come to the next step, in which we try to monetize these impacts. Now this is life, so it's not in a monetary terms. We have to take the decision in monetary terms. So we take it in monetary terms in the next step. However, when we transform these impacts into monetary terms, there are difficulties, because in the CBA, the values, they are measured in terms of willingness to pay. And willingness to pay, when we inquire from the people, they usually do not represent the true values that they have for those resources. For willingness to pay, we need a demand curve as well, and for that we can do the surveys. But sometimes people, or most of the times, people hide their willingness to pay because they are afraid that they will be charged if they reveal their willingness to pay. And if there is no individual who is willing to pay, then the value of that resource or intervention will be zero, which is quite strange and discouraging for the state to intervene. Also, for those things that are in the form of intangible situation, that is the satisfaction or happiness, that is something which is difficult to assign a dollar value to, because these are non-traded items. So this is another difficulty that we face when it comes to monetization. When we consider the example of the highway, following are the components of the monetary value of the time saved. So what we do is we come up with a monetary value of an hour saved by each type of traveler. Hour is the time unit that we base our analysis on, and each unit of time saved is to be assessed for its monetary value. We know that we can use the hourly wage to find out the monetary value of the time saved. If we start with the layer time, there is layer time, and there is business time, and there is truck driver's time. So these are the three categories of time that we are considering. And for the leisure time, people will be having time saved for leisure, and for that what we can do is we can use a kind of percentage of their gross wage as the value of their leisure. For example, we can say that gross wage, it's 25% when we multiply it with the average number of passengers that are traveling, then we get the leisure time saved per vehicle, because in every vehicle there will be different number of passengers, and we can take its average, and then we can calculate the product with the monetary value, and 25% of the hourly wage we consider as the value of leisure time. So in this way we can get the leisure time saved per vehicle, and then the business time saved per vehicle is already calculated, the details of which are not given here, and here the truck driver's time is also calculated by using a certain formula. If we gather all these three time values, then we can get the time saved monetary value. Then we can also try to calculate the monetary value of the statistical life. For example, $50,000 per life. This is an estimate which is done. Basically, this is another detailed topic in which we can try to quantify the lives for their monetary values. And also we can try to assess the monetary value of the accidents that are avoided due to newer highway. Once this cumbersome exercise of quantifying the benefits and the costs and monetizing them is done, then we come to the discounting of the benefits and the costs in order to get the present value. Because the project is in the future, and when we talk about future, the discounting is required because of time preference rate. We will delve deeper into this concept as we go ahead, but right now the simple thing is that there is a preference of consuming now as compared to consuming later. So the resources, they have greater value now as compared to any other point in time in future. We want to consume now as compared to any time in future. So there is time preference, due to which we try to discount the resources with a certain percentage, which is basically dependent upon the discount rate, which is developed by the planning machinery of various countries. In case of Pakistan, it is Planning Commission, and they suggest this value as 12.5 in Punjab Planning Development Board. So this is the formula that we will use to calculate the certain factor that we use for discounting. Now coming back to the descriptive part, it is the time preference, and also there is opportunity cost that is faced when we use these resources in a certain project. We are foregoing some other opportunity, due to which there is a cost, and we should try to incorporate that cost in the analysis of this project, due to which there has to be discounting. So these are two major reasons due to which we do the discounting. Now this value that we get after discounting should be called as present value, because it is the value which is from the present point of view, that is now. There is no universal value, as I also mentioned that there are various planning commissions and authorities that determine the discount rates. It is basically mandated by the government agency, which is responsible for financial and budgetary outside of other government agencies as well. So they are looking at other government agencies, and they are responsible for financial and the budgetary outlays, so that they determine, in the light of all the factors, the state of the economy as well. in order to determine the discount rate. This is the formula that we just referred to, and we can do the certain calculations to find out the discount rate. We will do this thing when we go ahead, but right now, just as a hint, if the discount rate is S and if it is 15%, then in this place we will write 0.15, and if it is for 10 years we will use 10, that is, it will start from 0 and it will go to 10. So in this way, this calculation will be done, and once this calculation is done, it is multiplied with the benefits and multiplied with the costs. As you can see in green color and in red color, we have introduced these terms in this product with this term of the discounting factor. Once we discount the benefits, they become present value of the benefits and they become the present value of the costs. Then there is another thing that we need to understand regarding the time span and the discount rate. If the project is spanning less than 50 years, then it is an intra-generational project which is related to one generation. And in this situation, we can use constant discount rate that will remain the same throughout the project. But if the project is spanning beyond 50 years, then it is an intergenerational project because it goes beyond one generation lifetime, that is 50 years. So we can use time declining discount rate here. Logically speaking, if we keep a constant discount rate, it will fade away the benefits and the cost drastically because the time span will get larger. So we try to decline the discount rate over time so that discounting does not excessively eat away the benefits and the costs in the process of discounting. So in order to keep the intensity of discounting low, we try to use time declining discount rate. Now we have the computation of the net present value of each alternative, which is the seventh step, and it is quite easy once if we have done the previous steps. This is the present value of benefit. We will substitute it here. The present value of cost, substitute it here. Taking the difference, we get the net present value because it is the present value, but there is a net element in it, that is the difference of the values with respect to benefit and cost. Now the decision rule should be set here. If we have a single alternative of a project which is being compared with the status quo, then we simply need to check if it is having a positive NPV, that is the NPV of the alternative, which means that the present value of benefits of the alternative minus present value of the costs of the alternative is greater than 0. Shifting this term to the right hand side, it becomes this inequality, which clearly means that for this alternative the present value of benefits is greater than the present value of the cost, which makes this project desirable as compared to the status quo. But if we have more than one options, then we have to choose either one of them, which brings us to the case of mutually exclusive alternatives. And in that case, we rank all the possibilities with the help of their NPVs. Here we are considering that we have 3 alternatives and we have found their NPVs and we can simply compare them. It is a condition that NPV, all of these NPVs, they are at least one of them has a positive NPV, because if none of them has a positive NPV, then definitely the status quo would be desirable, as status quo would be without any negative NPV. So this is that situation. Another consideration is that NPV of the first alternative, of the second alternative, and the third alternative, their values, they are not zero or they are non-zero, and in that case status quo will be in place. So this is another way of writing the thing that we wrote here in this way. Now we can try to understand the selection with the help of this diagram when it comes to alternatives. Here what we can see is that we have output on x-axis and the benefits and the costs of the intervention on y-axis. The benefits, they have an increasing trend, but the increase is decreasing over time, so it is a positive slope but increasing at a decreasing rate. The costs, they are increasing but at an increasing rate. So the shapes of these curves are like this. Now out of these various options that we have in order to produce various levels of output, Q0, Q1, Q2, Q asterisk and Q3. Q0 is the output of status quo, that is, there is no intervention. So this Q asterisk seems to be the highest value because most useful output, because in this case the distance between the benefits and the cost curve is the highest. So the maximum net benefits, they occur when we produce this much of the output. So the alternative related to this output is the most suitable alternative. Most efficient resource allocation is moving towards this point, and optimum point is this one. This is the most efficient, whereas these are getting more efficient as we move from left to right up to this point. Now the caveat is NPV criterion applies only to the specified alternatives, and those alternatives that are not specified, for example, in between Q2 and Q asterisk, there are other alternatives that we haven't quantified. So we are omitting those possibilities. This is one thing that we must remember. Then we have despite other alternatives might conceivably better. There can be other alternatives that might be better, but definitely there are constraints on our time and the human input and the financial resources. So we have to choose among those that we have quantified and analyzed. NPV criterion asks us to do this thing, that is more efficient allocation of the resources, and it might not be able to give us the most efficient allocation of the resources because we are not able to analyze all of the possibilities. A set of proposed projects is there in which Q1, Q2, Q asterisk and Q3 were there, and output scale was increasing when we moved from Q1 towards Q3. BQ and CQ were the cost and the benefit curves that we just saw and understood the trends of, and these are the increasing and the decreasing rate things that we just saw in the diagram. BQ is increasing at a decreasing rate, CQ is increasing at an increasing rate. Q0 was at status quo, Q1 was at relatively small scale, and those small scale alternatives were these. As you can see, their order is given. So the net benefits from Q1 are greater than 0, and the net benefits from Q1 alternative are greater than the net benefits from the status quo. As you can see, it is giving us greater benefits as compared to the Q0. So status quo should be ruled out, we should not undertake it. As the scale is increasing, the optimal scale is being approached, and it occurs at Q asterisk. And when output is greater than Q asterisk, the net benefits will start declining. As you can see, the points after this Q asterisk, the distance between the Q, B and C now has started to decline. So this is that point where we should stop and avoid any further decline in the net benefits. The net benefits are positive when the benefit curve is above the cost curve. These are the small scale alternatives. As you can see, these are the small scale alternatives because output is up to this level. And after this, there are large scale alternatives, but the net benefits, they start to decline. Here you can see at when the net benefits are 0, the BQ and CQ are 0. It happens at 2 points, that is at this point the net benefits are 0, and at this point again the net benefits are 0. The net benefits, they are less than 0 once we enter into the large scale dimension after crossing the optimum scale of Q status. If the analysts evaluate only two alternative projects, that is Q1 and Q2, clearly Q2 will be recommended. So if we are constrained by the alternatives that we have or the resources that we have, these two alternatives, if they are analyzed, then Q2 will be opted for because Q status will be out of the domain of our analysis. So these constraints can really put brakes on our ability to analyze and come up with the most efficient alternative. So if NSB of Q status is maximized, Q status is the most recommended as it is not among the set aware. Is not recommended because it is not among the given alternatives. So even this is the most suitable, this will not be recommended because our analysis is up to Q2 in this case. NPV criteria leads to a more efficient outcome, not necessarily the most efficient, because we are not able to analyze all the alternatives, all the outputs. So there are constraints, and due to those constraints there is cognitive capacity limitation and there is bounded rationality, which means that cognition, time and imperfect information, they exist and we cannot recognize all the possible benefits and the alternatives that we can have in this situation. So these problems, they arise. Budgetary constraints are there, we know that, and political constraints are also there. Due to lack of political will, we might also be restricted to analyze all the alternatives. So these are the features of this type of situation. In this second last step, we can conduct the sensitivity analysis because we know the life of a project is uncertain, due to which the predicted impacts, they can change considerably, and due to which the result of the project can change also. So appropriate monetary valuation was done, but due to the prediction regarding the number of lives saved, the dollar value that we should assign to the statistical life, and also the discount rate, the social discount rate, its value, it can be imprecise as well at times, and also the appropriate level of standing, it should be determined. But we can expect that there will be approximations and misestimates in these and other variables, due to which there will be uncertainty, and we should consider those miscalculations in advance and set a range of possible and affordable values that are feasible for the project, beyond which the project will become infeasible. So we should keep an eye on those critical variables and do this analysis. Again, this process of sensitivity analysis, sensitivity to the critical factors, is also limited because we have constraints of time and resources. Finally, we talk about the final step, and this final step is about making the recommendation. Generally, what we do is we choose the project with the largest NPV, and in this case we had 4 NPVs in that table. The NSB of the no tolls from the global perspective had the highest NPV. The NSB of the no tolls dimension from the provincial perspective had a lower NPV, and then the NPV further declined when we considered the toll dimensions alternatives from the global and provincial alternatives perspectives respectively. Now this has a negative NPV. It clearly shows that one should go for status quo because this is undesirable, and we should go for status quo. Now the no toll alternatives, they are superior to with tolls alternative because toll can discourage the travelers. But it might not be the case that we go with the intuition. There are other factors that determine the final decision. Basically, the tolls, they deter people from using the highway, and lesser people will enjoy the benefits of the highway. The analysts, they make recommendations and not the decisions. The analysts are not in the position to decide if they should make this kind of highway or that kind of highway. The decision should be undertaken by the authorities, the people, the decision makers in the ministries. The CBA concerns that how resources should be allocated. This is a normative approach and not the positive approach. They decide that what should be. Decisions are made in political and bureaucratic arenas, as I already mentioned, that it is beyond the scope of the cost-benefit analysts that to make the decisions. So politicians and the bureaucrats, they are the ones who make the decision. CBA is basically an input to those decision makers, and CBA is not necessarily accepted. Politicians are often reluctant, and they are usually not persuaded by the economic arguments. They might have their own political and vested interests, due to which they might overlook the economic side of the things, which is highlighted by the cost-benefit analyst. So the surprising result of all of this exercise is that the highway was built with tolls, and you remember that the tolls option was in one of the provincial perspectives, it was negative, that is undesirable, and it from the global perspective, however, it was desirable, but still having a lesser value of NSP as compared to the no tolls alternatives. So initially it was made with tolls, although it was that the toll boats, they were removed in 2008. So you see, the decisions can be quite unexpected, and they can change over time as well because of the changes in the political arenas and the bureaucratic arenas as well. The decisions, they can change. So in this way, the 9 steps of cost benefit analysis, they have been mentioned here, and with the help of these details in the form of formula and diagram and label flowcharts, it is attempted to explain the 9 steps, which we will be explaining one by one and applying on various situations in our remaining course.